Almost everyone asks this question once, usually around the age of 7. If you climbed into a rocket, flew past the moon, past the last star in our galaxy, past the last galaxy in the sky, and just kept going, what would you run into? A wall, a void, the back of some cosmic room. Tonight, let's take the 7-year-old's question completely seriously, because it turns out to be one of the deepest questions in physics, and the honest answer comes in 3 parts. There is an edge to what we can see, and it isn't a wall. The universe isn't expanding into anything. And there's a real chance that the word outside simply stops working. Let's go looking for the edge. Start with what we can actually see. From Earth, our telescopes reach out into a sphere of galaxies called the observable universe, and it's centered, rather flatteringly, on you. That sphere is about 93 billion light-years across, which should bother you because the universe is only 13.8 billion years old. If light has only had 13.8 billion years to travel, how can we see anything 46 billion light-years away? The answer is that space itself has been stretching the whole time the light was in flight. A galaxy whose ancient light is only now arriving has spent all those billions of years being carried away from us by the expansion. Its light is a letter delivered from a house that long since moved to the far side of town. Add it all up, and the mail we're receiving tonight comes from a sphere far wider than the universe's age would suggest. So is that the edge? No. Hold on to this one idea, because everything else tonight rests on it. The edge of the observable universe isn't the edge of anything. It's a horizon. Stand on a ship in the middle of the ocean, and you'll see water out to a clean, sharp line in every direction, a circle centered exactly on you. No sailor thinks the ocean ends there. Sail toward it, and the horizon keeps retreating because it was never a place. It was a limit on how far you could see. The cosmic version is the same. An astronomer in a galaxy at the edge of our sky sees their own 93 billion light-year bubble centered on themselves, and from their deck, we are the ones out on the horizon. What's past it then? Almost certainly more of the same. More galaxies, more clusters, more of everything, running on far beyond our sight. How much more is a real scientific question, and the answers are absurd. A team at Oxford ran the numbers on the universe's measured curvature, and they concluded the whole thing has to be at least 250 times the volume of what we can see. That figure is a flaw, the minimum the data will allow, and most cosmologists suspect the real number is enormously bigger. The bubble we've mapped, every galaxy in every deep field image ever taken, may be to the full universe roughly what a single drop of water is to an ocean. Here's where it gets stranger. Out beyond a certain distance, the stretching of space adds up so fast that galaxies are being carried away from us faster than the speed of light. That sounds like it breaks the most famous rule in physics, but it doesn't. Nothing is allowed to move through space faster than light. There's no speed limit on space itself. And this has a dark consequence. The galaxies being carried away that quickly can never be reached, not ever, not even by a signal we send tonight at the speed of light. The expansion is accelerating, so more galaxies slip over that waterfall every year. Most of the galaxies in tonight's sky are already, in every way that matters, gone. We see their old light. We could never touch them. Now for the question hiding under all of this. If the universe is expanding, what is it expanding into? You've probably heard the balloon analogy. Galaxies are dots on a balloon's skin, and as it inflates, every dot slides away from every other dot. It's a good analogy with a famous trap in it, because a balloon inflates into the room around it, and so your mind quietly furnishes the universe with a room. Cosmologists mean something stricter. There is no room. The balloon's skin is everything that exists, and expansion just means the distance between the dots is growing. The universe doesn't need somewhere to expand into. It only needs its own internal distances to get bigger, and that's exactly what we measure happening. More space appearing between the galaxies, no outside required. Can that really be all? Well, that depends on the shape of everything. When astronomers measured the afterglow of the Big Bang with the Planck satellite, they found the geometry of space is flat as far as they can tell, to within about 0.5%. If space is genuinely flat and keeps its simplest form, then the universe is infinite. No edge, no boundary, no outside, just galaxies without end, and our little bubble adrift in the middle of forever. But sneak inside that 0.5% of uncertainty, and there's another possibility. Space could carry the faintest curve, closing on itself the way the Earth's surface does. Fly your rocket in a perfectly straight line in that universe, and you'd never hit a wall. You'd eventually come home, arriving from the opposite direction, the way a traveler circles a globe. Finite, yet with no edge at all. Notice what both answers have in common. Neither one has a wall in it. Either there's no outside because it never ends, or there's no outside because it curves back and encloses itself. There is one more idea, and it's the wildest, so let's be clear that it is an idea and no one has observed it. Some cosmologists think the burst of expansion that launched our Big Bang never fully stops everywhere, and that universes bubble out of it endlessly, ours being one bubble in an infinite foam. If that picture is right, then outside our universe there are others, with their own skies, perhaps their own physics. It's a serious proposal from serious physicists. It also may never be testable, so file it under maybe. Which brings us back to the 7-year-old in all of us. What's outside the universe? We can now give the grown-up answer. The edge you can see is a horizon, and horizons move when you chase them. The expansion needs no container, so there may be nothing to expand into and no wall to hit. And if the universe is infinite or curled gently around on itself, then outside isn't a place we haven't visited. It's a word that only means something from within. The child's question was never silly. It just turns out the universe's answer is stranger than any wall could ever be. You can travel forever and never once leave.